Okay, so now we're going to do an example of graphing a rational function. So you can see our function up top is x squared divided by x squared minus x minus 2. So the first step is to find x-intercepts, and in order to do that, we use the numerator. So our x-intercept is going to be what makes the numerator 0. So in this case, the x-intercept is going to be when x itself is equal to 0, because that's what will make the numerator 0. Go ahead and put a dot right away. Notice that that's also going to be our y-intercept, because that's when it crosses the y-axis as well. Second step is to find those vertical asymptotes. Using the denominator, we need to figure out when this would be set equal to 0, what x would be. In order to do that, we need to factor it. This is going to factor into x minus 2 times x plus 1. So this means that x equals 2 and x is equal to negative 1 are the vertical asymptotes. And right away we can go ahead and draw in those dotted lines, our dashed lines at x is equal to 2. And we should get into a habit of labeling them as well, so x is equal to 2. You should always label all asymptotes when you're graphing rational functions. And the other one is over here at x is equal to negative 1. Remember, the graph will never be able to cross vertical asymptotes, so that's going to help us determine the shape of the graph. The next thing that we're going to do is horizontal or oblique asymptotes. This one's going to have a horizontal asymptote. The reason for that is because the degree of the numerator is equal to the degree of the denominator. So to figure out the horizontal asymptote, we set y equal to those two leading terms. So y is equal to x squared divided by x squared, which ends up giving us just 1. So the line y equals 1 is the horizontal asymptote. I'm going to go ahead and draw that in. And of course we're going to label it. So y is equal to 1. Now, to determine if the graph is going to cross the horizontal asymptote, we set the original function, the x squared over x squared minus x minus 2 equal to the equation of our horizontal asymptote, which in this case is just 1, because y equals 1 is the horizontal asymptote. To solve, you need to multiply both sides by x squared minus x minus 2. We end up getting on the left-hand side x squared, on the right-hand side x squared minus x minus 2. And then if we solve, we can take away an x squared from both sides to get that 0 is equal to negative x minus 2. Adding x to both sides, we see that x is equal to negative 2. This is where the graph crosses the horizontal asymptote. So when x is equal to negative 2, it's going to cross the asymptote. Graphs can cross horizontal or oblique asymptotes only once, and to determine it, we always do this process where we set the original equation equal to the equation of the asymptote and solve. It is possible that it would not be able to cross, so keep that in mind as well, but it can never cross more than once. Now we have all of our critical values. We can go ahead and make an interval chart. Remember, your critical points for rational graphs are anything, any important x values, I should say. So the x-intercepts and the vertical asymptotes, basically what makes the numerator and denominator 0, are going to be your critical points. So in this case, we have negative 1, 0, and then positive 2 were our critical points. testing values in between each of these intervals to determine the behavior of the graph. Let's do x is equal to -2, x is equal to -1/2, x is equal to 1, and x is equal to 3. Just like before, we want to look at what the y values are. And if it's positive, it means its behavior is going to be above the x-axis. If it's negative, its behavior is going to be below the x-axis. So when x is equal to -2, y is equal to 1, which is positive. So this will be above the x-axis. When x is equal to -1/2, y is equal to -1/5, which is negative, so it's going to be below the x-axis. When x is equal to 1, y is equal to -1/2, which is negative, so it's going to be below the x-axis. And then finally, when x is equal to 3, y is equal to positive 9/4, which means it's positive, so it's above the x-axis. Again, these give us some nice points that we can go ahead and plot. For example, -2 we know is 1, which we actually already figured that one out because that's where it crosses the horizontal asymptote. When x is equal to -1/2, y is going to be -1/5. So we can go ahead and put a tiny little dot there as best we can. When x is 1, y is going to be -1/2. And then when x is 3, 9/4, which is about 2 1/4. So just like that. Now remember, the behavior of the graph is to get as close as it can to the asymptotes. So this one's going to try get really, really close to the asymptote, of course trying to go through those points that you sketched before. This right quadrant, in the first quadrant up here, because we know it can't cross vertical asymptotes and it's not going to cross the horizontal asymptote, it's going to look like that. Now, the left-hand side's a little bit tricky one. We know that it can't cross the x-axis again because there's no other x-intercepts. But we know that it needs to cross the horizontal asymptote at our dot. So that means it's going to follow this pattern so that it can cross at that point right where it's supposed to.